So again, number 9, right? So this is the opposite of what we have been learning since the beginning of chapter 4. Now, what if we are given um, the turning point and another point? How do we find the equation of the line? Okay, so let me read the question. Find an equation of the quadratic curve with a turning point at -2, comma 3, and which passes through -1, comma 5. All right. So when it says turning point, again, it is either the maximum or the minimum point of the curve. We don't know, right? What we know is that this is the um, turning point, or either the maximum or the minimum point. So therefore, this is HK, right? From the previous lessons that we had. So this is H and this is K. And then we have another point which is -1 and, or sorry, -1, comma 5. So how can we get the equation of this quadratic curve knowing H and K only? Yes, of course, we can find the quadratic curve by using this format here, right? The completed the square form. Okay, so because this is the only equation that has H and K on it, right? So therefore, using the completed the square format, we plug in -2 and +3 to this one. So therefore, we'll have y is equal to a times x plus 2. So it's plus 2 now, since this is -2. And then plus 3. So that's it. So that is your um, h and k inside our equation. However, we still need to find out what is a. Because we cannot, we cannot have an equation without any value for a. So how can we find that? Now, that is where the second point comes in. So it says that this point passes through -1, comma 5. That means that that particular point is also part of the solutions because it's along the curve. So therefore, we are going to solve for a using this point right here. And that's what I did on the second part, right? So solving for a, we substitute the value of xy from here to here. Okay, so obviously x is -1, y is 5. So using the same equation from here, so y now becomes 5, and then x becomes -1. Only that. And then you just solve for a. Okay, so after you have solved for a is equal to positive or simply 2. So basically, class, the equation of the line is y is equal to 2 times x plus 2 squared plus 3. Okay, this can be your answer, or you can still simplify this one and remove the brackets. Either way, yeah, it's just the same. Okay, so that's it for number 9. Okay, do you guys have any questions for number 9? Okay, so this one, it usually appears in some exams. I saw this a similar question like this when we were revising for IGCSEs. So this might appear again in one of your tests in the future. All right, anyway, that's it for number 9. All right, so for today, we are going to move on and we jump to 4.2. Roots of quadratic equation. If you have your textbooks, please go to page.
Can I see the previous slide, sir?
Yeah, okay. Page 69. This one or this one? This one.
Yeah, this one.
All right. Okay. So while Edgar is taking down notes, please guys take your textbooks and open on page 60. Wait, 69. All right, or 70. Okay. All right. Edgar.
Yeah.
All right. So finish.
Yep.
Okay, so let's go to chapter 4.2, roots of quadratic equation. Class, from here on out, you'll see this word more often, the word roots. when you say roots, okay, it's basically another word for solutions or answers. So when a question is asking for its roots, it's only asking for the solutions of an equation. It's like finding for x or for y. But basically, other word for roots is solutions. Okay, so you should know that one. Okay, so let's go here on page 70. Now, do you still remember the quadratic formula? This one. So we have learned this back in EMATS, right? I think 2 weeks ago. And also, let's go back from our examples yesterday. So just a while ago, we have graph something like this, right? So x plus 2 and then 6 minus x equals 0. Let me go back to those slides. All right. Okay. So here, class, the roots of this equation here are negative 1 and 7. All right. So these are called roots. These are the answers of this equation. And then for this one, for letter B, these are the roots of this equation. All right. So those are the roots. Okay. And then, yeah, similar with this one. Okay. So these are the roots. All right. So we know how to get the roots basically, right? By factorization or by completing the square. Now, for this one, I want to emphasize on the quadratic formula. Okay, because we can determine the root of a quadratic equation by using the quadratic formula itself. All right. So look closely, class. Now, this expression here inside the surd or the root sign b squared minus 4ac is a very important expression when it comes to finding the roots of an equation. Okay, because it determines the nature of the roots of a quadratic equation. What does it mean? What does it mean by when we say nature of the roots? It basically tells you if you have two different answers or two different roots. It also tells you if you have a similar answer or similar roots. Do you guys remember that when we have the same answer for both x, right? And then it also tells you if you have no answer at all within an equation. Okay, so using b squared minus 4ac at least lightens up your work because it tells you if there's an answer or if there's two answers or if there's no answer at all in an equation. All right, so it determines the nature of the roots. Now let's have an example. Okay. Um, and also, okay, wait, let me just check here. All right, so here we go. So let's have examples first before I discuss further use of the b squared minus 4ac. Okay, so let's have example number 6. It says here, solve the equation x squared minus 2x minus 1 equals 0. Hence, sketch the curve y is equal to x squared minus 2x minus 1, indicating the x-intercepts clearly. All right, class. Now, this b squared minus 4ac has a name. It has a name. Its name is discriminant, right? So the yeah, let me use blue instead. So it's called a discriminant because it discriminates the okay. This is discrimination in maths, not in other uses. It discriminates the roots of your equation. It tells you if you have a answer, or if you have two different answers, or if you have no answer at all. Okay. So anyway, let's solve this equation right here. Now, to solve this one and sketch this one, we need to find a, b, and c, right? A, b, and c. Okay, so from here, all right, you identify A, B, and C. I think everyone knows what is A, B, and C, right? So A is 1, B is negative 2, and then C is negative 1. So there we go, all right? Now, let's use the discriminant B squared minus 4AC right away. So we know if there's an answer, if there are two answers, or if there's no answer at all. Okay. So by using b squared minus 4ac, all right, our answer is equal to 8. Right? So basically, class, you just need to substitute everything a, b, and c on this expression, or to the discriminant, b squared minus 4ac. And then once you solve for this, you'll get positive 8. Actually, we're not after the actual number on this one. We'll use this later when we solve for the quadratic formula. But for this one, uh, what we're after here is the sign of the answer. If it's positive, 0, or negative. Okay, later I will tell you why. Now, if it's positive, which is our answer here, this means that you will get two different values for x. Just like our previous examples, we always get, or we always got two different values for x, right? All right, so that's okay. That's what it means when your answer here is positive. You will get two different values of x. So how do we prove that? So let's use the quadratic formula in solving for the values of x, right? So do you still remember the quadratic formula, guys? So this is the quadratic formula, all right? And then again, you substitute all the values of a, b, and c here. Okay, but this time, your work became a little bit lighter because, okay, so it's because, of course, we know b, right? It's negative b. So it's negative of negative 2, right? So it's positive 2 here, okay? It became a little bit lighter because you don't have to input everything back here again. Okay, so it's 8. So from your discriminant, we know that it's the square root of 8. All right, so you don't have to do it again. So it's already here. Okay, so you just plug in the square root of 8 and that's it. And then over 2 times a. So it's 2 times 1. So it's still 2. All right, and then simplifying this in your calculators, you will have, okay, by the way, class, in additional maths, um, we express our answer in third form, okay, in this format. So 1 plus minus is square root of 2, okay. We only change this to decimal when we plot the points on the x and y axis, okay. But for additional maths, we express our answer in third form. This is what we call thirds, okay. This is the third, okay. In other words, it's the root sign. All right. In other books, it's the third. Okay. So when we say third, it's the same thing with root. Okay. Square root, cube roots. All right. It's the same thing. All right. So basically, this is the answer here. When you plug this in your calculator, you'll get this: 1 plus minus square root of 2. So that means that these are your two answers: 1 plus square root of 2, and then the other one is 1 minus square root of 2. So those are your roots. Okay. Now, if you want in decimal, it's 2.4 and negative 0.4. Now, from here, I told you guys a while ago that you will get two different values of x, which we did, right? We have two different values of x. All right. So that's the use of the discriminant. All right. And then what's next? If we're going to sketch for this graph, we need to find for the maximum or minimum point. So here, since a is positive, that means our graph is happy, right? And if it's a happy graph, that means that the turning point is the minimum point, right? So again, how do we find for the x coordinate of the minimum point? So you just add this two, okay? So these are your x-intercepts basically, and then divide them by 2, and then you'll get 1, positive 1. And then for the y coordinate, okay, so using the same formula, this one, instead of x becomes 1, right, from here, okay? So your y coordinate for your minimum point is at negative 2. So therefore, the point is at 1 comma negative 2. And then after that, you just plot all the points here and here, okay? And then, so here and here, and then here. And then you just graph this one, and yeah. It will look like that. So that's it, class. All right. So do you guys have any questions, especially when it comes with the discriminant b squared minus 4ac? All right. No question at all. All right. All right. Now let's go to another example. Let's have another example. Example number 7. Okay. For example number 7, we have two questions. Wherein we need to find the roots of the following equations. Again, when we say roots, those are the value of x. Okay. X is equal to what? And then x is equal to another number, right? All right, so let's have letter A. So for letter A, we have x squared plus 4x plus 4 equals 0. So again, if the root is the question, you need to use the determinant. Oh, sorry, discriminant. Sorry. So solve b squared minus 4ac first to determine the roots. Okay, let's use the discriminant. Okay, when I say discriminant, I'm telling this one, b squared minus 4ac. Okay, so first thing is first, identify A, B, and C. So this is A, B, and C. So it's 1, 4, and 4, right? So by using the discriminant b squared minus 4ac, and then substituting everything from here to the expression, okay, so your answer here is 0. Okay, so what is the meaning when your answer is equal to 0? Now, if your answer is equal to 0, that means that you will get the same value for x. Basically, you will just get one answer because the two values of x will be just the same. Okay, it happened before, right? When we were doing some questions. All right, so that's what it means when your discriminant is equal to 0. This one, right? Again, if it's equal to 0, that means you will get the same value for x. Okay, basically, you just get one answer, okay? Because they're the same. All right, so how do we know the roots of this equation? Simply by using the quadratic formula. All right, so let's use the quadratic formula. So using the quadratic formula, so it's negative b, right? So it's negative 4 here, okay? And then plus minus, all right, that I think I forgot to write in the square root of 0. The square root of 0 is still 0, right? Okay, so square root of 0 over 2 times a, or 2 times 1, right? So this is what we have now in our quadratic formula. Very simple, right? So how did I get 0? From here, right? Just like a while ago in our previous example. Okay, so this is what we have now. So basically, you need to solve for the two values of x. So you separate the plus and minus. So negative 4 plus 0 divided by 2 gives you negative 2. And then the other one, okay, let me draw this one. And then the other one is negative 4 minus 0 divided by 2 is still also negative 2. Okay, so basically, class, we have only one answer here, which is negative 2. And that is, or those are the roots of this equation here. Okay, this one, negative 2. Okay, you can just write here, x is equal to negative 2. Okay, you can just write as 1 because they're just the same. Okay, so that's it. That's what it means when your discriminant is equal to 0. Okay, so if your b squared minus 4ac is equal to 0. Again, a while ago, it is positive, right? And for this one, it is 0. What if it's negative? What do you think will happen if our discriminant turns out to be negative? Okay, so let's have letter B. Now, as you guys can see, I think we can tell right away, right? Okay, so let's go with letter B. So again, let's use the discriminant first to determine the nature of its root. If we have one answer, two answer, or we have no answer at all. Now, for letter B, we have A as 2, B as negative 1, and then C is 1. So using the discriminant b squared minus 4ac, um, so just substitute everything again. Our answer will be negative 7. All right. Now, if your answer is a negative 7 in your discriminant, that means that there is no real root or there are no answers at all. So if you have a negative answer from your discriminant, that means that there are no solutions to this one. Okay. That's where we stop right away. Okay, that's why I don't have any quadratic formula here, because there's no point in doing those, because again your discriminant is equal to a negative. That's why there's no real root. Okay, so that's, yeah, so that's the use of knowing the discriminant of your roots right away. If it's positive, if it's a zero, and if it's a negative. Okay, so do you guys have any questions? All right. Okay. Now let's summarize everything. All right. Let's summarize. Okay. Again, if your discriminant is greater than zero, basically it's a positive. That means you will get two different answers, right? And then the second one, if your discriminant is equal to zero, basically you will get the same answer, just like the negative twos a while ago. And then if your discriminant is less than zero, or which in other words it's a negative, that means you don't have any answer at all. So it means you need to stop, or you don't have to go to the quadratic formula and solve for it. Okay, you stop right there. Yeah, that's it. Okay, so remember, if it's positive, sorry, positive, zero, or negative. Okay, it tells the nature of your roots. Okay, so we only have answers when it's positive and equal to zero. If it's negative, we don't have any answer at all. Okay, so that's it for finding the roots of a quadratic equation. All right, and then to explain it further using graphs. Okay, so again, it's just the same thing, class. I'm just using graphs here. Okay, so again, the b squared minus 4ac is called a discriminant for any quadratic expression. Okay, again, if your answer is positive, you will get two answers, right? Two different answers. Meaning, your graph will intersect the x-axis at 2 points, just like this graph here. Okay, that's why, yeah, your discriminant is positive. All right, and then for the next one, what if it's equal to zero? If it's equal to zero, again, we only have one answer, right? One answer. This is the graph of this one. Basically, class, that means that your curve will only hit the x-axis at 1 point, just like this. So it will only intersect at the tip, in the minimum or maximum point of the curve. That's what it means, okay? Now, in other words, this is what we also call a tangent, okay? Tangent. Again, we have encountered tangent in circles, right? We have a circle, and then you have a line outside, and then this point is what we call a tangent, right? Because it only intersects the circle at exactly 1 point. Same concept here. When you see the word tangent, that means that the discriminant is equal to zero. Okay? And then of course, if your discriminant is a negative, that means that the curve will not even intersect the x-axis. Okay? So that's why there are no roots to that quadratic expression. Okay? So this is how they look like. Because eventually, in the future, we'll have some questions when it comes with graphs. Okay? So yeah, that's it for the discriminants. All right. Do you guys have any questions about finding the roots of some equations? Okay. All right. So can you please go to page sorry, page 73. Okay, page 73 in your textbooks. Okay, exercise 4.2. Okay. All right. So I'll answer letter A from number 1. All right, this one. And then I'll give you guys a few questions to answer also under number 1. Okay, so let's have number 1, letter A. Okay, so I have prepared this last night. All right, so number 1. So the instruction here tells us that we need to use the discriminant to determine the nature of the roots of the following quadratic equations. when the roots are real, okay, find these roots. Class, again, the discriminant is the b squared minus 4ac. It's the name of this equation. And then again, when you determine the nature of the roots, you find out if the answer of your discriminant is equal to a positive, 0, or a negative. All right, that's the nature. Positive, 0, or negative. Now, if your answers are real, which is either positive or equal to 0, that means you need to find the roots of the equation. Okay, so let me do letter A, and then later you'll do two questions. Okay, so on letter A, we are given x squared minus 2x minus 5 equals 0. So to use the discriminant, we should identify A, B, C first, right? So A is 1, B is negative 2, C is negative 5. So using the discriminant b squared minus 4ac, substitute everything here. Okay, so we have negative 2 squared minus 4a times c is negative 5. My answer is positive 24. Again, if my answer is positive, I will get two different answers or two different roots. Okay, okay, so let me use the word roots. Okay, but it's just synonymous to the word answer. Okay, or solutions. Two different roots. Okay, so if we have a positive or equal answer, I mean equal to 0 answer, that means you need to find the roots, right? So to find the roots, we use the quadratic formula. So using the quadratic formula, okay, it's negative b, right? This one. So it's negative of negative 2. And then plus minus, again, you don't have to write the whole b squared minus 4ac again. You just write this, your answer here to this one, because it was inside this, right? Okay, so it made our work a little bit light. All right, so 24, and then over 2 times 1, or 2 times a. Okay, so this is our quadratic formula. And then simplify this. So this one becomes positive 2, and then 2 times 1 is 2. And then you separate the plus and minus the square root of 24. So plus and minus the square root of 24. And then class, you just use your calculator for this, and it will give you 1 plus root of 6, and then the other one is 1 minus root of 6. So that's it. So that's your answer or answers for letter A. So we have two different roots. Okay, again, it says to use the discriminant, right? So it's the b squared minus 4ac. So in order for you to use this, you need to identify first what is a, b, and c, whereas it's 4, 4, and 1, respectively, right? So substituting the values of a, b, c in your formula, your answer will become equals to 0. Did you guys get 0 as your discriminant? Okay. Oh, sorry, I'm not screen sharing. All right, so here. All right, so again, letter B. So 4x squared plus 4x plus 1 equals 0, right? So you need to first identify A, B, and C, which is 4, 4, and 1, okay? And then using the discriminant, B squared minus 4AC, your answer will become equal to 0, right? So again, guys, did you get 0? Okay, if you get 0, that means you will get two same answers, or two equal roots. All right, two equal roots. Let me use the word two equal roots. Okay, now once you're here, of course, that means that we have answers, so we need to use the quadratic formula for that. So here's the quadratic formula. It's negative of negative, sorry, it's negative b, right? So it is negative of 4, and then plus minus is square root of what? Of 0, okay? 0. and then over 2 times a, or 2 times 4. And then separating the plus and the minus 0. So we have negative 4 plus 0 over 8 gives you negative 1 half. And then negative 4 plus 0 divided by 8 is also negative 1 half. So that's it. That's our answer for letter B. Do you guys have any question for letter B? Okay, so again, if your answer is equal, sorry, if your discriminant is equal to 0, that means you will have two equal roots. Okay? And then for letter A, if your discriminant is equal to a positive, that means you will have two different roots or distinct. The word is different. Other uses is distinct roots. They're just the same. All right, and then letter D. Okay, obviously for letter D, we got a negative answer for our discriminant, right? So, but first of all, how did you get A, B, and C? Because it was written like this, right? So first thing you need to do is to change this question here and then rearrange this the same way as letter A, letter B, okay? So you distribute x, so it becomes x minus 3x squared equals 2. And then you rearrange them, okay? So putting this forward, negative 3x squared, and then plus x, and then transpose 2 to the left side, so it becomes minus 2, and then equals 0. All right, so from there, you can now identify your A, B, and C, which is negative 3, 1, and negative 2. All right, and then let's use the discriminant, b squared minus 4ac. So once we have this, your answer is a negative 23, meaning that there are no real answers, or actually, yeah, basically there are no answers for this one. Okay, so that's it, guys. Do you guys have any other questions?
Can I see the previous slide, sir?
This one. Okay, so here, your discriminant b squared minus 4ac is equal to 0. All right. For letter A, your discriminant b squared minus 4ac is greater than 0 because it's positive. And then jumping to letter D, okay, your discriminant b squared minus 4ac is less than 0 because it's a negative. All right, so those are the important things that you need to learn today about finding the roots of quadratic equations. All right, do you guys have any other questions? Okay, so I'm going to discuss maybe one more example. Okay, all right. Okay, so example number 8. All right, so you have this on your book, but please do listen for some keywords. Now, example number 8, you'll find this on page, okay, page 71, 71, page 71. Okay, all right, on page 71, example number 8, let's find the values of p for which px squared equals 2x minus p, where p is not equal to 0 and then has equal real roots. All right, class. So again, you see the word. So you see the word roots, right? So if you see the word roots, usually we use the discriminant to figure out the answer for this one. Okay. So how can we get the values of p wherein this equation has equal real roots? What do we mean by equal real roots? Okay. That means that your discriminant is equal to 0. This one. Okay. This is what it means. Equal real roots, meaning your discriminant is equal to 0. And that's how you solve for p. All right. But then how do we start? How do we begin? Of course, we begin by identifying A, B, and C from your quadratic equation from here. Okay. So what do we need to do here? We need to rearrange this, okay, to its standard form, wherein px squared and then minus 2x, okay, you transpose it to the left side, and then plus p, this one, equals 0. So this is the standard form of a quadratic equation. And then from here, identify A, B, and C. In this case, class, our A, B, and C are numbers and what? Variables, which is P. So A here is P, and then our B is still -2, it's a number, and then C is equal to P. Okay, any question, class, about that one? All right, none? Okay. So we have A, B, and C, and then again, it says here that the root of this, that this equation here has equal real roots. So that means that its discriminant is equal to 0. Okay, so from here, we substitute the values of A, B, and C to this equation. So A is P, B is -2, C is P. So B here is -2, so it's -2 squared minus 4, and then A is P, so that's why this is P, and then C is P again, so that's why this is another P, equals 0. And then we just solve for P. So simplifying this, you'll get 4, and then simplifying this, you'll get negative 4P squared equals 0. Okay, and then you transpose negative 4P to the other side just to make it positive. And then how do you solve for P? So basically, you need to get rid of 4, divide both sides by 4. So it's only P squared equals 1. And then how do you get rid of the square here? So you get the square root of both sides. So therefore, P is plus and minus 1. So that's the value of P. All right, so that's it for example number 8. Do you guys have any questions? So be particular with these keywords. Equal real roots. That means that the roots or your discriminant is equal to 0. Let me jump to number 9, example number 9. But this one, I won't be able to explain this since we are out of time. And then for example number 9, just for this one, okay? So you're given this quadratic equation, and it says it has no real roots. If it has no real roots, that means that your discriminant is less than 0, okay? And then take note of the question, find the range of values of k. When you say range, that means you're talking about inequality here. Inequality, all right? See, it's because of this one. It says that this quadratic equation has no real roots. So therefore, you will use the discriminant, which is less than 0. That's why your answer is a range of values. It's an inequality. Okay, that's why my answer here is 3 over 4, or k is less than 3 over 4. Okay, and then do I have another one? Okay, and then for number 10, just this one. I haven't finished this. When you say real and distinct, that means that your discriminant here is what? Greater than 0, or it's a positive. Okay? Yeah, so that's it. If p is greater than 1. Okay, whenever you see this, these are the keywords, class. Real and distinct. That means your answer here is positive. Your discriminant is equal to a positive. And again, if it says no real roots, your discriminant is a negative, or it's less than 0. And then again, if it says equal real roots, your discriminant is equal to 0.